little delay.
limitation of the platform.
Yeah.
So you have but you can speak over the video to explain the picture.
Yeah.
Okay?
Quanta história cabe em uma década? E quanta história ainda pode ser escrita? Há exatos 10 anos, a mineração Usiminas oferece minério de alta qualidade, sempre com segurança e respeito ao meio ambiente. Nosso produto, hoje, é enviado para algumas das maiores siderúrgicas do mundo. Mas nossas raízes seguem firmes, nos lembrando sempre de quem está próximo, ajudando na construção dessa história diariamente. Em 2019, alcançamos recorde anual de vendas, produção e exportação. E acreditamos que o futuro promete novas conquistas, como o fim do uso de barragens convencionais nas nossas atividades, já a partir de 2021. Muita coisa já foi feita, muito ainda está por vir. Vamos juntos construir o amanhã? Mineração Usiminas, mineração em dia com o futuro.
Nós estamos aqui e somos essenciais. Produzimos de forma responsável e segura insumos para todas as indústrias, do agronegócio à indústria química, para a construção civil e geração de energia. Estamos presentes em todos os setores da economia. Somos o início, somos matéria-prima. Estamos no DNA dos equipamentos médicos, respiradores, camas hospitalares, bisturis. Possibilitamos a comunicação na ponta dos dedos. Nossos produtos vão do conteúdo até as embalagens de medicamentos. Estamos até mesmo nas refeições de todos os dias. Nós somos a indústria que produz insumos para todas as indústrias. Podem contar com a mineração. IBRAM, Instituto Brasileiro de Mineração.
Tudo que é essencial não pode faltar nesse momento de pandemia. Pães, frutas, legumes, hortaliças e os inúmeros produtos da indústria alimentícia. O Brasil é o maior exportador de alimentos do mundo. Mas para que o país continue produzindo para a sua mesa, somos imprescindíveis. Seja para adubar, corrigir ou fertilizar o solo, estamos sempre presentes. O nitrogênio, o fósforo, o potássio e o calcário são minerais essenciais para o agronegócio. E se hoje não falta alimento durante a pandemia, é porque nós continuamos trabalhando junto aos demais setores. Nós somos a indústria que produz insumos para as outras indústrias. Podem contar com a mineração. IBRAM, Instituto Brasileiro de Mineração.
Vivemos num momento que o lugar mais importante de todos é na segurança da nossa casa. E cada pedacinho dela foi feito a partir dos agregados fornecidos pela mineração para a indústria da construção. E quando tudo isso passar, você poderá circular por estradas, viadutos, túneis, pontes e calçadas. Tudo construído com areia, brita, cimento, aço. Também produzimos o calcário, sílica, alumínio e minério de ferro, que serão a base do cimento e do concreto de construção. Juntos, esses bens minerais darão forma e composição para as estruturas das construções. Casas, prédios, hospitais, comércios. Não importa onde você esteja, uma parte de nós sempre estará com você. E se hoje não faltam materiais para a construção civil nem para a infraestrutura, é porque continuamos trabalhando. Nós somos a indústria que produz insumos para as outras indústrias. Podem contar com a mineração. IBRAM, Instituto Brasileiro de Mineração.
Um dos minerais mais valiosos da Terra, o ouro, é essencial para a nossa sociedade. Presente desde a antiguidade, deu origem às primeiras moedas e ainda é usado como segurança financeira pelos países. Sua utilização na arquitetura é uma das mais conhecidas, assim como na moda e no design. Porém, sua utilização é muito mais ampla. Bom condutor de eletricidade está nos chips e processadores de TVs, celulares, computadores e equipamentos médicos. Excelente refletor está nos satélites artificiais e como catalisador na indústria automotiva. Sua capacidade precisa permite cirurgias vasculares e visualização no microscópio eletrônico de varredura. Se hoje não falta ouro para os equipamentos eletrônicos, nem para suas outras inúmeras finalidades, é porque continuamos trabalhando. O ouro, como os outros minerais, faz parte de uma indústria essencial. Nós somos a indústria que produz insumos para as outras indústrias. Podem contar com a mineração. IBRAM, Instituto Brasileiro de Mineração.
Quanta história cabe em uma década? E quanta história ainda pode ser escrita? Há exatos 10 anos, a mineração Usiminas oferece minério de alta qualidade, sempre com segurança e respeito ao meio ambiente. Nosso produto, hoje, é enviado para algumas das maiores siderúrgicas do mundo. Mas nossas raízes seguem firmes, nos lembrando sempre de quem está próximo, ajudando na construção dessa história diariamente. Em 2019, alcançamos recorde anual de vendas, produção e exportação. E acreditamos que o futuro promete novas conquistas, como o fim do uso de barragens convencionais nas nossas atividades, já a partir de 2021. Muita coisa já foi feita, muito ainda está por vir. Vamos juntos construir o amanhã? Mineração Usiminas, mineração em dia com o futuro.
Boa tarde a todos, né? Muito obrigado aí a participação, juntar com a gente aí para a gente apresentar essa tecnologia, parabenizar e agradecer ao IBRAM por essa oportunidade, né, da gente estar podendo trazer algo novo para o setor de mineração para o Brasil. Rapidamente, a ARP Consultoria é uma empresa relativamente nova, a gente tem pouco mais de 2 anos de vivência no mercado, mas a gente sempre vem buscando aquilo que tem de mais moderno em tecnologia e inovação, tanto para o setor mineral também quanto para o setor, outros setores, principalmente o setor de energia. A gente está investindo muito em treinamentos, em busca de inovação. Temos algumas parcerias importantes. Nós temos um engenheiro nosso hoje que está fazendo mestrado nos Estados Unidos e temos uma parceria com a Universidade Federal do Rio Grande do Sul. E nessa busca nós encontramos a Happy Monitoring, né, uma empresa da Suíça que desenvolveu uma tecnologia de monitoramento de estruturas usando o geoprocessamento e a inteligência artificial. Quem vai falar para a gente hoje é o diretor técnico e desenvolvedor da tecnologia, o Sr. René Schneider. Hoje ele é o diretor técnico e responsável por todo o suporte técnico da Happy Monitoring. Ele tem mais de 35 anos de experiência adquiridos em laboratórios de inovação de uma das maiores empresas de equipamentos de precisão e monitoramento do mundo. Então, eu vou deixar agora com o René, que ele possa fazer a apresentação. René, please, can you start your presentation? Thank you.
Yep. Good afternoon. A greeting from Switzerland to all my friends in Brazil. It's an honor and a great pleasure for me to talk about Happy Monitoring. Just a moment. That is a new technology that I will present you, how you can make monitoring with GPS. When we go to the first slide, the beginning of a new era. A lot of you will thinking, yeah, I know GPS monitoring, that is technology that is known. I will guarantee you, end of this presentation, some of you will think that is not possible. So I will start with a small technical part, and then we go directly to the existing installations that we have, that you can see the results, the problems, all what we have done in the last 4 years. First of all, the conventional methods that you know sure, that are normally manual measurements, total stations, GPS or radar systems, extensiometers, inclinometers, you know that all. All these systems have some advantages and disadvantages. Now I will show you what is the reason why we have made Happy Monitoring. First of all, Happy Monitoring work with real-time kinematic system and not post-processing. The people that know GPS, they know that normally for monitoring, we have to use post-processing. Happy Monitoring is the first system that works 100% with real-time kinematic. So, what is the situation of GNSS in this moment? We have begun with GPS, the American system, then the Russian system, European, and now the newest one, the Beidou, the Chinese system. Now that there's more than 130 satellites in the sky. Our approach was that the most sensors that you know work on a GPS-based solution. That means the sensor needs GPS satellites to calculate the position. We have found a sensor that we have developed that is not GPS-based. It works also alone with Galileo, alone with Beidou, or all together. That is clear, normally all together. This is important why the new satellites, Galileo and Beidou, have very strong signals and very high accuracy. So we can choose the best systems for our solution. What we need for happy monitoring? We need only power, 12 volts. We need internet. I will show you that will be in some places for you a problem. We need open sky. We can't measure in a tunnel. And I need a geologist, a specialist that can say to me where is a fixed point for the base. How works happy monitoring? We have our sensors that are connected with internet in cloud, and they send every 5 seconds a coordinate to a data server. Important, there is no RTCM raw data, only fixed coordinates. 5-second rhythm is our experience, is the best sequence for the data. So we have in about 70,000 points per day. Then what is new? The calculation. Normally, when you have existing monitoring systems and you need to integrate new sensors in your existing system. So we have decided to create a XML request. That means you have from your own portal the possibility with an XML request to take the data, the results out from the server. That means you don't need to change on our system. You can use your system that exists and combine the data with other sensors. Clear, we can give you also by FTP server the results every day, every 3 hours. How do you like it? And we have also our own web page. I will show you that. The calculation is quite simple. We have a request on the data server. The data will prepared go to our computation server. Here inside is the intelligence of the system. Here inside all the calculations are made. And then with this result, we can use alarm systems. We have some systems that work with barriers that goes down, that close the street and something like that. Now I like to show you one of the first installations, that's more than 3 years now, that it works. That is the most dangerous village in Switzerland. He slide in about 1.5 to 2 meters per year, and the people lives there. It's a very nice region. It's in the Swiss Alps. And this whole village is sliding. You can see the church is not vertical. This mountain is falling down on the village. There is one sensor in the center of the village. This is the housing for the robotic total staging. This is a sensor in the sliding zone. Here we can have in about 4 meters of snow. So the pylon is really high. So I will show you. I will connect me now directly to the sensors. We can go on our link, and you are now in this moment connected with our sensors in Brienz. I can show you here, for example, the situation where is the point. We are in the city center. And what I like to show you now, how was the decision to go on happy monitoring for the Swiss government? What is the request? To understand where is the problem, I like to show you the situation. And I think this problem you have also in all dams or bridges. That is a common problem. When you see the geological situation, you have here the mountain that's falling down. But you can see here, all the region, it's not stable. So the problem is they have installed 15 years ago robotic total stations, inclinometers on this mountain. But the problem is that also the total station here is sliding. So the request from the Swiss government was, we need a system that we can go with the base here in this region. That is a geological stable point. And we have here in about 3 kilometers of distance to the points in the sliding zone. Now Happy Monitoring gives the coordinate to the total station in this region. Last year they have installed also a radar system that also have the position from Happy Monitoring. And so we can help the other system from a point far away to give extremely high precision positions. I can show you, for example, a point that is from July 18. These are the graphic results from the beginning to now. What is impressive when you see the green line is the height. We have a precision in the position on 3 kilometer distance of 0.8 millimeters every day. But when you see, I slide a little bit with the height is in about 3 millimeters on 3 kilometers. It doesn't exist another system that can measure that.
René, sorry, interrupt you, okay? The video is not working. If you check it, if you have any problem, you can show it again, or
okay. Just a moment.
Please check it, because I have already received a message for the audience that the video is not working. Please check it, please.
Yeah, it's now.
Sorry to interrupt you, okay?
Yeah, I have checked now. I may stop. Excuse me. You can see now.
Just a moment, I think, let me.
Excuse me, you can see my video.
I think it's better you go direct to the PowerPoint. Oh, sorry, PowerPoint, to the YouTube.
I'm on the PowerPoint now.
No, sorry. Maybe it's better you go direct to maybe you can share the other screen. You are sharing only the PowerPoint screen.
Yeah.
So go in the bottom of the.
Yeah, I see that.
You see, so share the YouTube.
Yeah.
YouTube screen.
Yeah, I'm on the PowerPoint now.
So, but you need to share the. No.
Huh.
No, you have to share the other screen. The screen where is the video.
Okay. And now you can see.
No, I am seeing.
That is not possible. Bildschirm. You don't see.
No. Open the video in your computer.
Yeah, but it's you can
So
see
go
me.
there is in the bottom there is share screen.
Yeah, I know.
So click on the screen, the video screen.
Yeah.
Have to work.
Monitor Google Home. I don't understand. You can see this one.
Yes.
This one you can see.
Yes, the graphic I can see.
Okay. Okay. Now, so I go a little bit back. Excuse me for the technical problems. I can show you the, situation. Now you can see me. Hello? I hope you can see me.
Yes.
Okay. Thank you. What I like to show you here.
People now is seeing you.
Okay. So I like to show you one of the biggest landslides that we have in Switzerland, only to explain you what was the request from the government for this landslide. In the city center or village center here, we have in this moment robotic total stations. Here is a radar system. We have inclinometer, extensometer, all what you can imagine. Problem, when you show the geodetical situation, we have this region is all sliding. So the request was that we can measure from 3 kilometers away, it's here, we have a stable region, to measure high precision points in the village center and on the slides here. You can imagine the same problem you have with dams, bridges, everything you like to monitor. Normally now for high precision, you have to go near. Now with happy monitoring, you can go far away. And what I like to show you, it's especially the height precision. The green one here is the height precision. In this case, we have on the point, the position precision of 0.8 millimeters, and in the height, 3 millimeters, 3 kilometer distance. That is, I'm sure, the unique system that can measure heights in this precision. So I have to go to my presentation. I have explained you what was the request from the government. We have installed 3 sensors in the slide, and the accuracy of these measurements. This is an email from the responsible from the government, and he was by the University of Zurich to make the calculations about the precision of the system. You can see 0.5001 is the point in the village center. 5002 and 3 is the point, are the points on open sky.
René,
and these are the precisions.
René, sorry, we cannot see your screen.
Now?
We have still the same graphic. Now we see you.
Yeah. And now?
Your PowerPoint.
Okay. So I can show you the results of a calculation of the University of Zurich, where the calculation was made on the point in the village center, and the 2 points, they are open sky. That is horizontal precision, 0.8 and 0.7 millimeters on 3 kilometers baseline. That is the comparison about a GPS system with post-processing in the same place in Brienz. We have there also 3 sensors that work with post-processing. And you can see that is post-processing, and the red line is happy monitoring, and that is 3-dimensional speed measurements in millimeters. Very high accuracy of happy monitoring. Now, how we can do that? We can do that because we use no GPS-based sensors. We have an intelligence inside the sensors. And then we have our unique intelligent algorithm that calculate this high precision. We have implemented a kind of artificial intelligence that the algorithm is learning in the time to be extremely much better in height measurements. Position less than 1 millimeter, it's quite the maximum. We have direct acquisition of coordinates. That means the result can be only one coordinate. The people from you that know post-processing, they know the same raw data, 10 different persons, 10 different results in the calculation. Happy monitoring, one result. And something that is really interesting, every satellite give us more precision in the system, and we can go longer. I will show you. We have 2 types of sensors, the Hawk and the ADA. ADA is a special sensor for railway monitoring. The system is plug and play. You don't need a specialist. The system will connect by the cloud servers by himself. All is cloud. You can, by your smartphone, control the system everywhere you have internet. The accuracy, we say we are always 3 times better than every system that you can find on long distance. We can work without weather influence. When you know robotic total station, all optical systems have some problems. When you have rain, fog, snow, we know not. We can work with the same precision in every condition. With the low energy consumption of the system, we can work also with small photovoltaic panels. And now I show you some references. I think that it's for you more important to see what we have done. First of all, it's a very difficult installation. That is, they built a tunnel under the railway, and we have to measure only the height of the traverse in a precision of 3 millimeters. But the problem is the track is open. Every 5 minutes we have a train. So the train goes over the sensor, stop the fix, and the sensor have to refix, and 3 minutes later the new train is arriving. That is for the German railway company. First, the request was every 6 hours, one height point in height precision of 3 millimeters. After 1 year, we was by every hour, one point in this precision. Typical question now in Europe, all what is bridge monitoring. And this bridge is an old steel bridge, and it is more important, the height monitoring of this bridge than the position. The engineer like to know how the deformation with different temperatures work on this bridge, and the results was impressive. We have now different works in Germany for bridge monitoring. That is something when you have volcans. That is Ischia, a small island in Italy. We have here had in 2017 an earthquake that have destroyed all the region. In the point 2 is in the center of the magma chamber. The distance is 2.5 kilometers here. And what we have measured for the first time in the history of this island, that the island is going up, down every 6 days. That is a rhythm. And with the geologists, they have found out that this exactly is the pressure in the magma chamber. The whole island is go up and down. And with this precision, we can detect that, and also, that is clear, make an early warning system before the next earthquake. That is a landslide monitoring of a very slow landslide. There is about 3 centimeters per year. And so the installation here was quite difficult when you see the right point on the right picture. That is on a wall. For GPS, not ideal installation. But finally, also in this situation, we have achieved a precision of 3 millimeters in position. Our services, installation, support, we can help you when you have existing systems where we can use also happy monitoring inside. Early warning systems, integration in your existing internet structure. And so to contact me for all technical parts, special parts, especially for you, Antonio Harley, for all questions in Brazil. Now I hope I can change my screen and show you some real installations outside of my presentation. You can see me now. I hope you can see this screen. Can someone confirm me that you can see it?
Yes.
Okay. That is our last installation made this year. It's the most impressive installation that we have ever made. And so I like to spend a little bit of time to make you understand the possibility that is always that you have a mountain, a dam, or a mine. The problems are always the same. I need 3-dimensional high precision coordinates. Now, the situation here is on the top of this mountain, here is the cross. This side is Austria, this side is Germany. And in the last 20 years, the mountain has begun to crack in the middle, exactly on the border. The University of Munich works about 10 years now with extensometers, scanners, drones, total stations on this mountain. Professor Dr. Krautplatter, the responsible, asked me to give him an information about which side is sliding. From the geological vision, that is clear the Austrian part is sliding, but they are not sure because all the measurements are relative to the crack, but not absolute in the position. And I have here some impressive pictures. You can see here are the extensometers. They go in about 40 meters down and they measure all this situation, but only relative. So we have installed a base station here in the valley, and we go up on the top of the mountain, 5.5 kilometers distance. And what is new, the height difference is 1.5 kilometers. That I will show you after that the results. Professor Krautplatter said when you achieve plus minus 3 millimeter in position and 7 millimeter in height, it will be really impressive to have this data because the long extensometers have plus minus 2 millimeters of precision. to imagine you the situation. This is happy days, simple happy days. And we measure here the 2 points on the top of the mountain. Please register this image when we show the results. That is the real distance, 5.5 kilometers. In this mountain, another problem, we don't have internet. We have found a solution with a specialist from Germany, a really low-cost solution. With the small antennas, we can bring internet 15 kilometers with a local area network. And that is quite impressive, it's high speed. That for a lot of installations, we can work with that. Or when we're completely out in Amazonia, the best is with satellite phones. The price for satellite data now with the effort from Elon Musk, from Tesla, it's really going down. Here are the points on the mountain. Here in the bottom of the valley is the base. That is our point on the Austrian part. And this is the point on the German part. It's quite a nice place. Here are the results. That is, we have had in the first 2 weeks of measurement, all the weather conditions or bad weather conditions that are possible. From heavy snowfall to thunderstorms to extremely rain, because we are now in the summertime. And in the summertime, in the high level of the Alps, the weather can change from 1 hour to the other. And so it was really, from the weather situation, really bad. I show you here a table, Excel sheet. This is the calculation of the distance between the 2 points. Every day, one calculation, the distance between the 2 points. You can see we are in tenths of millimeters of precision. And then it begins to open. And we have checked this data with the extensometer results. We have in about 1 millimeter of slide of the Austrian part and the extensometer 0.8 millimeters slide. So the verification of the precision was 3 times better than the University of Munich have requested. What is also impressive, these are the difference of the coordinates. That will mean the single vector from the valley on top of the mountain, point 1, point 2. And we have, that is clear, we have the slide of 1 millimeter inside. But the point that we think now it's fixed have a precision of 1 millimeter, 5.5 kilometers, 1.5 kilometers height difference. So you can applicate this extreme situation on everything that you do. And the most important thing is the height precision. For the first time, we can long distance control vertical displacements of a dam, of a sliding zone. And that is happy monitoring. It's quite a new era of monitoring. So from my part, it is all. I am open for questions. There are some questions.
Pessoal, I was speaking in português, né? Pessoal, então agora, quem que tiver pergunta, pode mandar aí pelo chat. Nós vamos fazer o possível para poder responder aquelas perguntas agora. Se tiverem outras dúvidas, por favor, nós podemos responder depois para cada um de vocês aí a cada pergunta. Então, fiquem à vontade. Aí, se quiserem fazer pergunta em português, pode fazer que eu faço a tradução para ele. Ok? René, there is the first question.
Yeah.
Let me check here. Where is it? The first question. Oh, I need to come back here. So, where is the question? Just a moment. Just a moment, please. I need to reconnect it. I left the. Just a moment, please. There is a question, someone asking, what kind of artificial intelligence is using the...
I'm not the right person to respond on that. I have my specialists. I know artificial intelligence, for that I have said a kind of. It's a system that learns about the statistics. That I know, but how it works and what is the name especially of that, I don't know. I can ask, but I'm not the guy that make the software.
Another question is Maria Luisa is asking if exists another system, a kind of replacement system, I understand it, to identify any fail.
Ooh. I don't understand.
Let me try to explain what she wants to know. If Maria Luisa, me corrija se eu estiver errado. A sua pergunta é se falhar o sistema, se tem um outro sistema que seria substituto a isso? É isso mesmo a pergunta? Enquanto ela me responde, she asked me, there is another question from Dylan Lorca. He asking if the system needs the direct vision or not.
No, absolutely not. Absolutely not.
Okay. Another question is from Luciano. There is a possibility to use another kind of sensor, for a gas sensor, for example.
Yeah, we can use it. We have to check. It can be when the sensor is GPS based, the precision can be less. But we have also make tests with other sensors, and it works.
Okay, Maria Luisa, I understand now her question. The question is there any backup system in a case of a fail of the system?
Yeah, that is, the sensors are with auto start. First of all, when the power is turning on, they make the work and begin to measure. That is clear for all servers. We can install the servers directly by the customer. So that means, for example, a big company have their own server and is responsible for the backup systems.
There is another question this is a friend of mine, Teresa Fusari. Thank you, Teresa, to join us. Teresa is one of the most respectable, most known professional in dance in the world. So this question always is very important. She asking if the sensors are not GNSS sensors.
What?
She asking if the sensors the sensors are not GNSS sensors.
Yeah, there is a GNSS sensor, free frequency. The new one, the Hawk, work also with the new frequency from Galileo Beidou, up to 5 frequencies. No, that is the top of high precision sensors.
Okay, another question from Jonathan. Does Rapid Monitoring consider using LoRa or XB to make a connection from afar?
Yeah, we have made some tests with LoRa because the University of St. Gallen in Switzerland have a point, and that is clear. We can use LoRa by Wi-Fi connection for internet. So the advantage is that we can use small solar panels because the power consumption of LoRa is extremely low. The speed is no problem. We don't need a high-speed internet. We send every 5 seconds a coordinate. So no necessary to have a speed in the internet.
Another question from Darren Lorca. How many sensors can be connected to the same receptor or gateway?
On the same gateway? Oh, that is a question that normally on a base you can unlimited sensors connect. Then the quantity of sensors that I can take on the same gateway depend on the speed, on the quantity of data that I can use. But we have made tests with 40 sensors. That is quite nothing. We use 5–10% of the internet. That is to calculate when we have the data from the gateway.
Another question, Darren again. The system always monitoring online just in time, or the lectures or are sent to in package to the receptor?
I don't understand.
No,
Can you repeat
what
it?
I understand, his question, he's asking, the monitoring is continuous, or
Yeah.
or it makes the some reading in some space in some pack and put it packing it just one information and send it.
No, the system is always connected, is normally on permanent monitoring, but on building sites, for example, we have also that the customer leave the points 2 months on one sector, and then he take the sensors and go to another sector. For that, the plug and play is so important. You don't need a specialist. You plug the power, the sensor work. We, in the central for mapping monitoring, we must know when you have changed the position to give a new algorithm to the point. But that is no problem.
Alguma outra pergunta, pessoal? Any other question? Eu que agradeço, Daya. The question, there is a question from Luciano. I think I can answer it direct in Portuguese. He is asking about the if we pay for the rent of the sensors. Não, Luciano, isso como eu vou explicar para você como é que a gente vai trabalhar. A gente faz um projeto para você com a estrutura de qualquer que seja, tá? A gente vai avaliar a sua estrutura e nela a gente vai ver quantos sensores são necessários para você ter o seu monitoramento. Os sensores são vendidos, né? E o serviço de monitoramento ele é mensal, um valor mensal, anual, depende do contrato, tá? Mas não é locação. There is another question. How does the maintenance work? Can you answer it, René? How does the maintenance
antenna
work?
works? I don't understand the question.
How does the maintenance work? How can we maintain the system?
Okay,
if there is
okay.
upgrade in the system, everything like that.
All by remote control. We can new firmware all the connections. When the customer gives me the permit, I can go by cloud into the sensor. I know that now that we have a lot of new satellites, they need updates the sensors, but we don't need to come to Brazil to do that. We can do that from our center.
Mais questões, pessoal? Estamos aí à disposição, nós ainda temos um tempo aqui. Ok, vou passar. I'm sorry, people on chat ask me for my contacts. So I will type my contacts for them now.
Yeah.
My email and my phone. Luciano, ok, eu vou deixar aqui no chat, já tinha passado o e-mail, eu vou repetir o e-mail, ok? E também vou deixar o meu telefone, sem problema nenhum, tá? Então tá. Meu e-mail e o telefone. There is another question. Yes, I know that. Does the system can be applied to the transmission lines? Yes.
Yeah, we have done that.
Yes. There is another very interesting, you can apply this in the conveyor belts for the mining as well, for every kind of structures. Okay.
Exactly. Also transport systems, for example, in minings, all the things that must be in a direction that you need height and position control. On long distance, clearly, we can go really, really long distances in high position.
Estamos à disposição aí, que nós ainda temos aqui uns 10 minutinhos. Daniel, eu vou te responder. Eu tenho a apresentação, ela vai ficar disponível no YouTube, tá? E todas as apresentações que estão sendo feitas durante a mineração, elas vão ficar disponíveis por um período, eu não sei qual direito, mas vai ficar lá. Se você precisar de mais informações, eu tenho aqui folders da tecnologia. Você pode acessar também o site monitoring.com, né? Lá você tem mais informações no próprio site, tá? E qualquer outra informação que você precisar, com meus contatos, você pode me entrar em contato, que eu estou à disposição para qualquer informação que você quiser, tá? Another question, René. If there is any possibility to combine this system with smart grids?
With smart? What was the name?
Smart grids. It's the new trend in it's a new trend in the power sector. Everything is connected, from the power generation to the
okay, yeah. We work in cloud. You can connect all together the systems. That is with the XML request, how I have explained. that you can automatically connect the systems with other kind of systems. So that is, we don't need software. We are totally in internet, in cloud.
Daniel, respondendo mais uma vez a sua pergunta a respeito da apresentação, eu recebi a informação aqui agora do pessoal do IBRAM que as apresentações ficarão disponíveis tanto no site E-Mineração, né, também no YouTube do IBRAM. Tá? Another question, René,
Yeah.
from Darian again. He asked, which is the frequency we need to set up or calibrate the system?
To calibrate the system?
Yeah. For
we
example,
don't need calibration.
I don't need calibration.
No.
So you don't need calibration. Always, okay.
Yeah, but for example, the question is, I know that every year you must make a calibration of the sensor. No. We can also change sensors. They are broken with new ones. No calibration need. It's calibration free.
Ele respondeu sua pergunta, Dainan? Okay, he understand. Yeah, okay. I asked him if Dainan if it's there is a question for another friend of mine, Lucas Brazil. He's another very nice guy. We have worked together. I think I will answer him because he asking the system can be used associated with another one as a second monitoring tools like a redundancy. Yes.
Yes.
Yes. The question is
normally it's like this.
Yeah. A very good question again here. How does the system react to the extreme weather conditions?
Yeah, because we use only sensors. They are EP68, highest military standard, and we don't have every pieces outside of the sensor. So that is really highest protection. We worked in the mountains by -40 degrees and on the railway track by 85 degrees. Never had problem with rain, all the problem. That is really high military standard.
Antonio, excuse me, it's Eduardo from the organization. I have 1 minute left, so could you please introduce to the end of the session, please?
So, vou terminar então.
So I think, first of all, thank you all for the participation on this meeting. And excuse me for the technical problems. I hope you have understand what we do. Perhaps you have other questions. Please send it to Antonio. I will respond you also of all other questions that you have. Thank you very much.
Pessoal, agradeço aí a todos, né, pela participação e as perguntas. Eu espero que vocês tenham entendido como funciona o sistema. É realmente uma evolução do monitoramento, é aquilo que eu falei no começo. A nossa empresa está sempre buscando a inovação e as melhores, né, tecnologias. Estou vendo que está chegando mais questões aqui, mais perguntas. Eu peço que encaminhem para o meu e-mail, eu já coloquei aí, tá? E fiquem à vontade em entrar em contato comigo. Estou disponível 24 horas por dia, meu e-mail está aí, meu telefone. A intenção é essa mesmo. E, mais uma vez, né, parabenizar e agradecer ao IBRAM por essa excepcional oportunidade, não só para a gente que somos os fornecedores da mineração, não só da mineração, mas como outros importantes setores da economia, e uma belíssima oportunidade para a gente trazer uma nova tecnologia aqui para o Brasil. Parabéns, IBRAM, muito boa, né? E contem com a gente. Muito obrigado, viu?